Okay, this is July 10th, 2025, 6 scale. I want to close on the performance chain, the performance change we've been reviewing for a little while. Okay, here's Lubo. Hey, hey Lubo. So I want to close on this topic, and then send out to the mailing list what our conclusion was on the performance change. So this is what I've been able to come up with so far, and um, basically been able to summarize here is that in the transition to from 1.25 to 1.27, we noticed this change. You can see it right here on the left side in September 2023 that this was the provider transition. Actually, let me see if I can hold on a second. All right, I'll just tell. So this line right here, I was going to go to I was going to go to the table that shows what this is, but this line is the transition from Kubernetes providers from 125 to 127. And we had observed this. We even talked about at KubeCon that this change occurred, and we didn't really know how to explain it. We thought that there was a performance improvement in Kubernetes originally when this happened. Um, but our trend line was originally at the P50 was around 20, close to like 18, and then went down to about 15. So we saw this change, and then you can see again when we go to the later releases like 126, you can see that here we are again, we're still at 15. When we look at what we've been talking about with our trend line, let me see if I have one. Um, oops, I think this is what I need. So our trend line is back up to 20. So here, let me just do a side by side again with that. So you look at this graph right here, right? So this trend line actually matches this trend line here, right? It's about 20. So we really just went back to the trend line that we were at before the change, which to me, like this points to the fact that this had to do with the change from 125 to 127 originally, and that had to do with resources. The resources from 125 to 127 on the Kubernetes control plane changed, and that affected our job. We can see that with the number of create requests that went in, that we had looked at the past, that we were creating less than a full amount of VMs. And that's what affected it and caused the trend line to dip to 15. And it wasn't a performance improvement, it had to do with resources. And then we returned to the prior trend line from 2023 again, which is about 19, 18 or ish, somewhere around there. And that's what is actually been our historic trend. So we're actually what ended up happening is the way to put it is that we had a period where we weren't getting accurate data and for the performance, and it was compressed. And so now we're going to be getting accurate data again. What do you guys think? I mean, that's kind of my conclusion. I think that seems to fit what we've been seeing, and um, it seems to fit what we've been kind of we haven't been able to locate a PR that caused this, and it seems to be exactly has to do with when um, the CI infrastructure received increased resources
Yeah, uh,
back here in February.
I think this makes sense to me. The only thing I'm wondering is how can we, what improvements can we make to the tests that we catch those infrastructure problems where the numbers are not accurate?
Yeah, yeah, Lubo, go ahead.
Yeah, so hopefully share the link with you about the rehearsal runs. So we should review
Yep.
these because basically it's like we increase the memory for the job and tried a couple of times to run this. And that should make sure that there are less workloads on the node at the same time. And hopefully, I believe it's more about CPU contention that we experience. And that's why the performance drop went up, or the 50, 90, and 99. And this rehearsal should be showing the better numbers now. If that's the case, then we can just uh, merge the PR 4194, and that should help at least immediately. And then for long term, I want to try to set up a CPU manager on the cluster and set the like make sure that we have dedicated CPUs for this job. And the same time, we can also monitor the jobs if the pod is actually under some contention. So these are two things I want to try next.
Okay. So let me write these down. So hold on. Okay, so I think first thing to light, I did go to back to you. I think it's this metric. Um, this create pod counts is a way we can measure reasonable accuracy. Create pod count. It's gotta be over 100. Um, I think that's one of the learnings. I think first of all that it has to be doesn't need to be exact at 100, but it just needs to be greater than or equal to 100. I think that's that first thing is that has to happen. Okay, so now second thing is this one. So Lubo, this is increase the memory. Increase main requests. Uh, already was. Okay, so that should help us. Let's review these though, just to make sure. So we should see, okay, 18, 28. So that means 28, 18. Okay. Yeah, this is like our historic trend. So we're in this is what we expect. Let me look at like one or two of these here just to be sure. 11, 17, 28. Okay. Also within what we expect. Then let me go to I don't know, one of the early ones here. 11, 23, 29. Yeah, so kind of on the upper bound of this trend line, but still within reason. Yeah, I think Lubo, this seems to check out. I mean, these are this is showing that I think this is showing what we expect to see.
Yeah, I think as well. The numbers seems to be lower. Sometimes they just jump up, but yeah.
Well, so when you say lower, sorry, what do you mean? Like which number?
I mean, so
Lower.
for 95, it is 29. But was it supposed to be even lower? Let me see.
No,
Ah,
no,
yeah,
no.
it
So it
was.
should be here. It should be on. It should be actually. It should be slower. Like it actually should be higher. Sorry, the number should be higher than what we saw over here. It's the data should look like the data here, like after like March is the correct data. And that's the conclusion I'm drawing is that that is the correct data. This data over here is because we didn't have enough memory. So the numbers you showed by increasing the memory look correct to me. That should be 29, should 28. That's on the trend line, the correct trend line, which is this one over here.
Yeah, but it's more consistent. That's more what I wanted to say, right? It's not like 15, or at least I haven't seen 15, and then I haven't seen 49 define.
When you say consistent though, like so I understand what you mean. Like the data
So that
looks a little bit more like to the right side, or do you mean like to the left side of this
I
of my
think I
mouse?
think I think with the rehearsal, it's looking more like on the left side.
Okay, I was
So
saying it looks more like on the
this
right side. I was saying the
really
opposite.
okay. Let me check again.
Because the
I
so
think
here
I think
I'll go
you both
ahead.
are saying the same thing. Sorry, but what I'm understanding is that Ryan, on the right side of that graph, you see the spread from 15 all the way to 22, right?
Mhm.
So I think what Lobo is saying is that with the rehearsal, that trend line is more consistent in the 22 time frame, like
Yeah,
22 time.
This one, yeah.
like the spread is not that bad, right? It's not like from 15 to up to 100. It's like 15 up to 30, right? And the numbers were just made up, but
Yeah.
just to
So basically, the window is smaller between the lowest and the highest observed value.
So we have no more of these like zeros and no more of these like 21s, and then then this very compressed or this packed bunch of 15s in here. Like we don't have this anymore. Like that's the memory is showing a trend line that looks to the right side here where my mouse is. It doesn't show it doesn't show the left side anymore. I think that's where we're aligning, right? Is that because I'm looking at this data, it says 29 and 23, right? So P50 is to be 23. So it's like right here. It's this dot essentially. And then the one I showed before was like I think like a 16 or 17 or something, right? So it looks the data that you did on your rehearsals are over here. They're on this trend line where my mouse is. So the May to June, July trend line, and no longer on the December to February trend line.
yeah, that's correct. The
Okay.
difference is that yeah, so the actual value is higher, which can be explained by what you said that we just finally run those 100 VMs. By the way, we should have a check in that performance job to make sure that we never go below that. But while the number is high, it's not the spread is not high. So it's not like 29 and it can and it's plus or minus 5, right? So it's always or almost always 29, at least from what I'm checking.
Yeah, for the P95. Yeah, yeah, right. So right here. Um, and my mouse is on the end of the P50 where there's a little bit more spread. This is a lot less spread out.
Yep, just take a note that the graph uh, doesn't include the rehearsals. So
Yeah, yeah, I know. I'm doing it manually. I'm like I'm mentally plotting these, right? Like P95, 29 and 28, right here's 28. Um, I'm just mentally plotting them here like they would be on this trend line to the right, which is what I'm just saying that's what we expect, right? This is those rehearsals we want to be on the right side. That I think what that is further proves that theory that we needed more memory, right? There wasn't enough create requests. I think that's where we're landing. I think that's where we're all landing here. Um, that's what the problem was. Okay. I think so Lubo, like I think we're so late suggested this too. So I think what we need to do is the job needs to check this. We have to be over 100. I think this data over here, the reason we were getting 15s is because we weren't getting it we weren't checking this that the create pod count was over 100 because we weren't getting enough VMs because we didn't have enough memory. So we needed these results right here. Um, they're incomplete. I wouldn't say they're invalid. They're just incomplete. Like we're only getting some of the VMs. We're not getting all of them, and so it's not what we want to see. But the good news is that if you look at the historical trends, which I'm showing here at the P50, so P50, this is back in 2023. P50 is like, it's like 19, 18 or so. Um, we're pretty close to the historical trend line. And I can also grab the P95 here. Is about 30, and we're at 30. So it's over the time, really only thing that's happened is that we had uh some incomplete data for some period of time, but the we didn't have a regression. Right. I think that's the conclusion. There wasn't a performance regression. It was we had some incomplete data because of we didn't have enough memory for the job. And now we're going to be back having enough memory for it, and we'll have a check. I think we need to have a check to make sure that we check this in the future, make sure we don't regress again. Does that make sense for you guys? Do you guys agree with that idea?
So to me, I don't think it's about memory. I think it's more about the CPU contention, because even if we increase the memory for the pod, it doesn't necessarily mean that we increase the memory for the VMs running in the pod.
Okay.
It could
So
be it could be that the guest was also failing to allocate memory. I'm now thinking if that would actually panic the kernel, or it would still work. I guess it could work. Yeah, I guess you're right. That it
well,
could
I was
be.
gonna say we don't have to be specific. I would maybe put it simply as that. I was saying memory because that's how we were talking about it. We don't need to be specific. I think I would prefer actually we even just talk about this as the infrastructure had just more resources now. Um, and we'll increase the memory requests, and then we'll keep an eye on it with this where my highlighted is the create pod count over 100. If we have CPU contention again or whatever it is, I don't I'm assuming I don't know like that whatever it is that cause change Kubernetes could cause this again in the future, right? Um, and we just need to catch it. So that's how I was going to frame this, is that we didn't have enough resources, and this is how we'll catch it in the future.
Hopefully, yes.
Okay. All right. So, well, the good news is we are technically back on track and able to see um, these numbers and the complete numbers again. So that's good. Um, something we'll just have to keep an eye on. But I think that'll be our conclusion. And yeah, we don't need a release block. I think, Lay, did you ever file that release blocker for this or no? Was that I don't know if I saw it.
No, I think I just sent an email. Uh, there is no issue for this.
Okay. All right, then reply on the thread because there were some interested people that were responding on the thread and wanted to know what the result was. So I'll share the conclusion with this graph, probably both graphs, the P95 and P50, that highlights the transition from this side, and then again here from the infrastructure change. The resource, we'll call it the infrastructure resource change or something in February that caused us to suddenly show the complete picture again. Okay. All right, guys, I'll follow up with that one. We can close on this topic. And then Lubo, did you have anything else that you wanted to do with this? So you've got increased memory. What else did you want to do besides these two AIs here?
Yeah, two things. So one is to monitor the job to actually know if there is a CPU contention or what was causing the these kind of things. And second thing would be to implement CPU manager, so we can have a dedicated CPUs for this job.
Okay.
So I have one other question. Maybe this is something we might have discussed already, but want to brainstorm again. So I'm pretty sure that our tests wait for the VM to go into running state. And given that VMs can VMI or VMs, whatever the is, goes to running state, how would it be possible for the pod to not be created? Yes, that's something I'm not able to um, wrap my head around.
Yeah, I don't know either, Lane. I mean, maybe some of them were created and no, I don't know. Because if we can't even get to 100 in those cases, and the job is expecting 100, I don't know.
Yeah, I think that's something we'll have to look. It's another action item.
Yeah. Um, Hold on, I'm gonna quickly check this, but I'm just to make sure I didn't make a mistake with the assumption. Um, where am I looking? Here we go. I think it's a density test, right? Yeah. Um, it should successfully create all VMs. Select mentions wait running VMI.
Yeah, yeah, I think that check on line 95 is what should assert that the pod is created and is gone into running state.
Eventually, expect an error to not have occurred running 0 for. So what does it do? It gets a VM and then so it's given a VM object, it gets it, expects there to be no error getting it. It has a running wait running VMI, and it's gonna count. Then it waits till. Oh, so this gets the full list of. Oh, so this gets the full list of namespace test defaults. Is there any way this could be getting like VMIs from other jobs or something? Is that possible? I don't feel like that wouldn't be possible. We have our own namespace, right? And then it just creates it hits 100, starts from 0, counts up, sees 100 and running, and then done. I don't know. Yeah, I don't know what would make this pass if our metrics telling us we're not even getting to 100. Because the VMIs, once they're running, they're not going to fail. They
Yeah,
get some memory. And it's the new ones that'll fail. It's almost as if like the new ones, it's somehow seeing VMIs in this list that are, I don't know. I'm not actually sure. Like, I don't know what it would be looking at. I don't know how this would pass. It thinks it's looking at running VMIs, that's for sure. Thinks it's
Yeah,
looking at our running VMIs, the ones that it created. Yeah, I don't know.
yeah, we don't have to solve it here in this call, but that's surprising. I think that's the only missing piece to this entire puzzle for me.
Yeah. Yeah, I don't know. Maybe I can find a file initial for this and we can track it. I don't know. I'm looking at this, I don't know what the bug is, but um we can track it with an issue. I think there is an issue. I mean, we can see it in the behavior, but I don't know what it is. Okay. All right. I'll create some issues for these and we can that's how we'll track the work for these. And then I'll send out an email on the mailing list for our conclusion.
Yeah,
Okay.
sounds good.
All right, cool guys. All right, anything else? We got 1 minute left. Topics for today. I saw this was here. I don't know. Did you guys add this?
That was me. I wanted to ask you if you continued with the experiments and if you had any results for this one.
I'm trying to remember. We use this internally. Like, do you remember this? I think you've made some changes for this one.
Yeah, yeah. Yeah, we have extensive policies where um, all the requests from KubeWord service accounts go to a specific priority level, and then it's known for us that secrets and PVC listings are expensive. So all the secrets and PVC list calls go to a separate priority level, which is highly restricted, where it only allows 2 calls of secrets to be run concurrently. So we have those 2 things enabled in our cluster.
Interesting. Have you documented it somewhere, or like, do you want? Do you can?
Oh yeah, I think this was part of the KubeCon talk that we gave as part of KubeWord maintainer track. I think it was EU 2024. I can share that link with you.
Well, do
Okay.
you think we could? So I think this car was about like publishing some default API priority and fairness. So, like, do you think any of these could be default YAMLs that we can publish or
Yes,
resource that we can create? Okay.
yes, we should do that. In fact, I have a ticket internally where we should totally remove QPS and burst from KubeWord clients and have API priority and fairness at the server side as the defaults. Because that is the recommended practice from API machinery now that API priority and fairness has gone GA.
Okay, we should reopen this. All right, we'll reopen this and then Lubo, we'll take a look and see if we can publish what we have. Um, we'll see if we can between Elaine and myself or someone we can find some time to publish this what we have.
Yeah, thank you. Or if you have anything that I can read, that's fine as well.
Okay, sounds good, guys.
And you don't run evictions, right? Or are you running evictions?
We don't do the normal evictions using the eviction API.
Okay.
Yeah, Ryan can speak more to it, but we have our own workflow to evict workloads.
That's interesting because yeah, I mean, recently I stumbled upon too many cases where we do evictions and the eviction webhook is just kind of hungry. I think it's making like 3 API calls, one of which is list or something like that. So it can very quickly, for example, eat up the budget on the client on the client side. So that's what I was wondering if at your scale you're seeing this as well.
I think I'm trying to remember. We don't which is the eviction the I can't remember the where's the eviction controller live? You're talking about like in is this part of Qbert?
Yes, yeah, we have the webhook. Yeah, it's part of the QBeard, and we just registered it for every pod. Not right now, but we used to. But with every pod, just send the eviction request there, and yeah, that's what we used to do.
Wait, oh, okay. So we kind of do eviction a little bit differently. Okay. Yeah, I'm actually this is something I'm working on in Kubernetes right now, to change. Like we have like a bunch of like I started a new working group around this and like changing a bunch of things around eviction and draining. Um and it will affect KubeVirt eventually once we kind of get some things off the ground. But my goal is to like define and build some new APIs in Kubernetes for more richly expressing eviction so that you can actually do in-place draining.
Yeah, I need to join that. Do you have regular meetings already, or is it still
No, it hasn't. It
setting up?
just formed. It's like just officially got through like all the paperwork through like last week. So the regular meetings haven't started yet.
Okay, that's what I saw.
Yeah,
I
I can
was just
send you. It's called Node Lifecycle Working Group. I can send you the pointer to the charter if you're interested. But there should be meetings coming. I don't know when it'll start. Maybe like in any week now it'll start when we have all the stuff that we need to actually run the meetings.
sounds great. If you would just remember me and ping me, that would be the best.
Yeah, of course. Oh, I'll absolutely remember you, though.
Thank you very much.
All right, thanks, guys. All right, we're at time. Have a good day.